Remember that a second degree equation can often be solved by taking square roots. So just for a review, let's look at this example here. We have 3x squared equals 48. Okay, so remember the technique that we applied before was to isolate the x squared and then take square roots. So our technique says we need to divide by 3 to start with. We divide each side by 3, then we get x squared equals 16. And now we take square roots, and we get our answer, x is equal to 4. Now when we looked at this before, the only square root that we were interested in was the positive square root. But in fact, there are 2 square roots for every positive number, as you know, positive and its opposite. And in this section, we will be interested in the negative square root as well. So we will also allow for the fact that x could be negative 4 in this example. And you notice this symbol here, which you may not have seen before. This is read as plus or minus. This says nothing more, nothing less than the fact that x could be positive 4 or x could be negative 4. Okay, here's another example. 3 times x minus 1 squared equals 75. So again, we want to start off by isolating the square term. Okay, so we divide by 3, and this will give us x minus 1 squared equals 25. Now we can take square roots, and we get x minus 1 is equal to 5, or x minus 1 is equal to negative 5. And when we take those square roots, we have to allow for both possibilities. And now we have 2 equations to solve, and so we're going to solve each one. In each case, we need to add 1 to get our solution. In this case, it's x equals 6, and in this case, it would be negative 4. So we have 2 solutions to this second order equation. And the answer is sketched out here in the notes as well. Okay, so unfortunately, this nice technique does not always work with a second order equation. And the reason is for an equation like this, where we see not just the square term, but also a term which just has x in it. X squared plus 4x minus 21. This is an example of a general quadratic equation, ax squared plus bx plus c, where a, b, and c are any numbers. Now, to solve a quadratic equation, we could try factoring, and I need to let you know that this technique depends on the property of real numbers, that if you multiply 2 numbers and the product is 0, then one of those factors must be 0. Just think about that for a second. If you have any 2 numbers and you multiply a positive and a negative, then the answer is going to be negative. If you multiply a positive and a positive, then the answer is positive. If you multiply a negative and a negative, then the answer is positive. So the only way that you can end up with a product of 0 is if one of those factors is equal to 0. 0 times any number, let's say n, is equal to 0. So let's go ahead and solve this example. We have x squared plus 4x minus 21 equals 0. Now, to use the 0 factor property, we have to write this quadratic expression in factored form. So that's what we're going to start with. You remember when we learned about factoring, we saw that we could factor a trinomial by looking for factors of this number that would add up to this number. In this case, those factors are x plus 7 and x minus 3. Okay, now see, we have the product of two factors equal to 0, and so one of these factors must be 0. So we'll write down both possibilities. X plus 7 equals 0, or x minus 3 is equal to 0. So this gives x equals negative 7, and this gives x is equal to 3. So again, we do get two solutions. Okay, and it is sketched out here in the notes.